Hey there, science fans! It's Caitlin from 7 Solutions, and today we're diving into the fascinating world of volatile organic compounds, or VOC for short. Now, you might be thinking, VOC? Aren't those just those BTEX things? And you'd be right, partially. Benzene, toluene, ethylbenzene and xylene are definitely VOC all-stars, but they're just the tip of the iceberg. VOC are everywhere, from the air we breathe to the products we use every day. Some are harmless, even pleasant, like the ones that give freshly cut grass its smell. But others, well, let's just say they can be a real pain in the respiratory system. So buckle up, science fans, because things are about to get volatile. Okay everyone, time for a quick refresher. Now, VOC, or volatile organic compounds, are like those friends who are always the life of the party, but sometimes show up uninvited. They're organic compounds that love to evaporate at room temperature, meaning they turn from liquid to gas faster than you can say evaporation. Think about that fresh paint smell in a newly decorated room, or the aroma of gasoline at the pump. Those, my friends, are VOC in action. They come from all sorts of sources: paints, adhesives, cleaning products, you name it. Remember, knowledge is power. By understanding what VOC are and how to detect them, we can make informed decisions about the products we use and the environments we live and work in. Now, let's talk about a place where cleanliness is next to godliness: hospitals. Hospitals are like giant science labs, using all sorts of chemicals to keep things sterile and running smoothly. But here's the catch: many of those chemicals release VOC. Take anesthetic gases, for example. These are essential for putting patients to sleep during surgery, but they also release VOC like isoflurane and sevoflurane into the air. Then there are cleaning agents, disinfectants and sterilizers, which are crucial for infection control, but can also emit VOC. Now you might be thinking, Caitlin, hospitals have ventilation systems, right? And you'd be right. But even the best ventilation can't eliminate all VOC. That's why monitoring is so important, especially in areas with limited airflow or high chemical use. Alright science fans, let's grab a snack and talk about VOC in the food and beverage industry. You might be surprised to learn that VOC play a big role in what we eat and drink. And I'm not just talking about the delicious smells of freshly baked bread. Think about all those packaged foods we love. The adhesives and coatings used in packaging can release VOC during processing. But here's the real kicker. VOC are responsible for the unique flavors and aromas of many foods. That's right, those aromatic compounds that make coffee smell heavenly or give fruits their distinctive scents. You guessed it, VOC. Food manufacturers use strict safety protocols and monitoring systems to ensure that VOC levels stay within safe limits. Hold on to your circuits, science fans, because we're going high-tech. The electronics industry, with its shiny gadgets and cutting-edge technology, also has a hidden VOC secret. Think about it. Manufacturing those intricate circuit boards, powerful batteries and sleek smartphones requires some serious chemistry. Solvents are used to clean and etch components, adhesives hold everything together, and specialized materials go into those high-capacity batteries. And guess what? Many of these processes release VOC. The electronics industry is very aware of VOC and their potential impact on worker health and product quality. That's why they invest heavily in clean rooms, ventilation systems, and of course, VOC monitoring equipment. Those sophisticated ventilation systems, they're constantly pulling in fresh air and whisking away any lingering VOC. Now that we've seen where VOC lurk, let's talk about how we can sniff them out. VOC, or volatile organic compounds, are sneaky little molecules that can be found in various industrial settings. They can pose significant health risks and environmental hazards if not properly monitored. And for that, my friends, we have a special tool, the Photo Ionization Detector, or PID for short. This device is a game changer in the world of VOC detection. Think of a PID as a high-tech nose, but instead of sniffing out scents, it detects VOC by using ultraviolet light. This UV light is key to the PID's ability to identify and measure the concentration of VOC in the air. It's like a magic trick, but with science. The PID's UV light interacts with the VOC molecules, breaking them apart and generating an electrical current. The PID shines UV light on the air sample, and if there are any VOC present, the light breaks them apart, creating an electrical current. This current is then measured to determine the concentration of VOC. The stronger the current, the higher the concentration of VOC. This allows for precise monitoring and ensures that any potential hazards are identified quickly. Some use a 10.6 electron volt lamp, which is like a general-purpose VOC detector. It's versatile and can be used in a variety of settings to detect a wide range of VOC. But if you're dealing with trickier VOC, like those found in some electronics manufacturing processes, you'll need a PID with an 11.7 EV lamp. This higher energy lamp is capable of detecting more complex VOC that the general-purpose lamp might miss. So whether you're in a hospital, a food factory, or a high-tech clean room, a PID is an essential tool for keeping your workplace safe and your products top-notch. By using PIDs, industries can ensure that they are maintaining a healthy environment for their workers and producing high-quality products free from harmful VOC contamination. Now here's where things get really interesting. When we talk about VOC, or Volatile Organic Compounds, we're diving into a world of complexity and precision. VOC, like snowflakes, are unique. Each one has its own set of characteristics and behaviors. They all have different properties, and that includes how they interact with our trusty PID. The PID, or Photo Ionization Detector, is a crucial tool in detecting these compounds. You see, different VOC absorb UV light differently, which means they produce different electrical signals in the PID. This variation is what makes each VOC unique in its detection. It's like having a choir where everyone sings in a different key. Each VOC has its own voice that needs to be understood. To make sense of this VOC chorus, we use something called correction factors. These factors help us interpret the signals correctly. Think of correction factors as tuning forks for our PID. They help us fine-tune the device to get accurate readings. They help us adjust the readings based on the specific VOC we're trying to measure. This ensures that our data is reliable and precise. To make sure our PID is singing the right tune, we need to calibrate it regularly using a special gas called isobutylene. Calibration is a critical step in maintaining accuracy. Calibration and correction factors might sound complicated, but trust me, they're crucial for accurate VOC monitoring. Without them, our readings would be all over the place, making it impossible to get reliable data. Alright, science fans, ready for some pro tips on VOC monitoring? Today, we're diving into the essentials of keeping your VOC levels in check, especially in non-BTEX industries. Whether you're a seasoned professional or just starting out, these tips will help you maintain a safe and efficient environment. Whether you're running a hospital, a food plant, or a high-tech factory, these best practices will keep your VOC monitoring program in tip-top shape. VOC, or Volatile Organic Compounds, can be found in many different settings, and managing them effectively is crucial for health and safety. First things first, know your VOC. Understanding the specific VOC present in your environment is the foundation of any good monitoring program. This knowledge will guide you in selecting the right equipment and methods for detection. Just like you wouldn't use a telescope to look for microbes, you need the right PID for the job. A Photo Ionization Detector, or PID, is a versatile tool, but it must be chosen carefully based on the VOC you're dealing with. Identify the specific VOC used or produced in your industry, and choose a PID with the appropriate lamp and detection range. This ensures that your readings are accurate and reliable, helping you to maintain a safe working environment. Next up, calibration is king. Regular calibration of your PID is essential to ensure its accuracy. This involves using a standard gas like isobutylene to set a baseline and adjusting for any discrepancies. Regularly calibrate your PID using isobutylene, and don't forget those all-important correction factors. These factors adjust for the specific VOC you're monitoring, ensuring that your readings are as precise as possible. Remember, accurate measurements are key to effective VOC management. Without precise data, it's impossible to make informed decisions about safety and compliance. For areas with high VOC concentrations or potential for leaks, continuous monitoring with fixed detectors is the way to go. These systems provide real-time data, allowing for immediate response to any issues. Think of these as your early warning system, alerting you to any VOC spikes. This proactive approach can prevent small issues from becoming major problems, protecting both your workers and your facility. For spot checks and mobile monitoring, portable PIDs are your best friend. These devices are perfect for on-the-go assessments, allowing you to quickly and easily check VOC levels in different areas. By following these best practices, you'll ensure that your VOC monitoring program is both effective and efficient, keeping your workplace safe and compliant. Stay vigilant, stay informed, and keep those VOC in check. Congratulations, science fans! You've made it to the end of our VOC adventure. We've learned that VOC are everywhere, from hospitals to food factories to high-tech clean rooms. We've explored their hidden challenges and discovered the secrets to accurate monitoring. Remember, VOC are more than just BTEX compounds. They're a diverse group of chemicals with a wide range of properties and potential impacts. But with the right knowledge and tools, we can manage VOC risks effectively and create safer, healthier workplaces. Identify the source, assess the risks, and take appropriate action. And if you're ever in doubt, don't hesitate to consult with a qualified safety professional. And that's a wrap on our VOC adventure. Remember, whether you're in healthcare, food production, or high-tech manufacturing, VOC monitoring is critical for safety, compliance, and product quality. Thanks for joining me on this exciting journey into the world of VOC. I hope you learned a thing or two and feel empowered to create a safer, healthier environment for yourself and those around you. Don't forget to subscribe for more science, fun, and safety tips. And remember, stay curious, stay informed, and stay safe.